Okay guys, so day 2 of me being out. Yes, I am still recording this on the same day where I'm very sickly sounding, so I apologize that my voice is in and out. But if you haven't updated your table of contents, please do so now. I've got yesterday's and all the days before. We will have our test on Tuesday of next week, so you do need to make sure that your notebook is up to date. Keep in mind, if you missed the day before, you can look on Canvas for the notes. I'm not sure if the sub will do the best job of keeping up with the extra copies from the day before. So please check there and ask the sub as well. But I will have those up there. And just in case if your video is a little wonky, you can look at the clear see-through notes that I'm going to post to Canvas for yesterday, today, and even tomorrow. Okay, so please go check that out. Update your table of contents, pause this video if you need any more time. Otherwise, I'm going to go to the page where the notes are. It is just one page of notes today. Okay, so yesterday we talked about being able to tell if something has linear, quadratic, or exponential behavior. Today we're completely switching gears and talking about systems of equations with linear and quadratic. So this is 9.8 systems of linear and quadratic equations. This is on page 51. Now, you may recall from last semester that we did some systems of equations, and we did it with graphing, elimination, and substitution. Today we're just focusing on graphing. We're not doing anything else. So the first thing I've got to talk about with graphing. So the easiest way to do these are just to graph these two equations on graph both equations on the same graph and just see where they cross. However, there are three different types of solutions that exist. So the first one, if I wanted to graph the line y equals, and I'm going to highlight this in pink so you can tell which one is which, y equals x squared minus 4. Okay, so thinking back to those transformations I talked about, x squared is where it just perfectly is the parent function. So this is the parent function going down 4. So that's just something I remember. So this is me quickly graphing. So with this one, if I wanted to plug in values, at 1 I've got 1 squared. 1 minus 4 is negative 3. So when I'm at 1, I'm at negative 3. And since this is going to be a parabola, it's got to be symmetrical on the other side. So if I go 1 to the right, it's going to be the same 1 to the left. If I plug in 2, 2 squared is 4. 4 minus 4 is 0. So when I'm at 2, I'm at 0. And the same will be true over here at negative 2. Okay? And I can keep going from there. But my other line is y equals negative 3. Well, that's just a horizontal line at negative 3. So we can just directly draw that. Alright, I'm going to connect to my parabola. And my answer to my system of equations here is going to be where it crosses through at the graph. And if you notice, the first type of solution I can have is where there are two solutions. So that's where this line is going to cross through twice. So it crosses through once here, and that point is at negative 1, negative 3. And my second point is at